Hello, everyone. A very warm welcome and good morning to all of you joining us today. This month's Serverless Saturdays. This is Rushit Repakla, and I have Dharmendra with me.
Hello everyone, good morning all, and welcome back to the Serverless Saturdays. And this session will be very special for us today because we have two tech ladies. This is first time we are hosting two tech ladies together in our Serverless Saturdays. Yeah,
So yeah, really excited for two reasons. As one, Dharmendra has already mentioned, two women in tech, two AWS community builders, one an AWS intern right now, and more so special because she's our ex-colleague. She used to work at Confab, and some nice moments we have had in the past. And the other part is both the sessions are going to be about AI. I mean, with AI going everywhere, it is almost impossible that we cannot have an AI session on our side. So, without any further ado, we'll have Rashmi on the stage. Hey, Rashmi.
Hi. Hi, Sushit. Hi, there.
hello Rasmi, welcome to the Serverless Saturdays.
Thank you.
So yeah, Rashmi, thank you so much for accepting our invite to present at Serverless Saturdays. I know it's very, very late for you over there. It's what around 2 a.m. I believe in the night.
Yes.
So everybody, Rashmi is joining us from the US with her hectic schedule. She's agreed to join us, share her insights on serverless and AI. So Rashmi, over to you. You can introduce yourself, and the stage is yours.
Thank you. I think I'm gonna share my screen.
Sure. Yeah.
My screen is visible.
Yes, Rashmi. Yeah.
Yeah, sure. Um, Hi everyone. I am Rashmi Subhash. I'm an intern at AWS, and over the last few months, I have been building a few serverless projects with respect to AI, and I'm trying to solve like real world problems trying like in that particular space. And today I'm going to talk about this one particular problem that I'm trying to tackle is uh, the emergency AI assistant. Basically, the problem we tackled is when every second counts, the traditional dispatch systems can feel robotic and slow. Callers are quite anxious and the details can get lost, and dispatchers juggle between multiple inputs, and all of this is while racing against the clock. And this is the gap that we are trying to solve between we've got you and help is on the way. And this can cost lives. That is where my project comes in today, and this is what I am going to talk about. Swift Aid is our project, which is basically our AI powered emergency assistant. And today we'll see how Swift Aid can transform a basic frantic 911 style call into calm, guided conversation style, which buys precious seconds for actual people in crisis. For example, like imagine a moment where someone calls and says, I don't know what to do. And before they lose hope, Swift Aid can come in between, which can already be on the line, listening, understanding, and reassuring. And that instant response is what we built in this project, is what it is trying to achieve. So this is the basic workflow that uh, I made for the project. If this is visible, like I'm just gonna like first walk through and then I'm gonna play like how it actually works. So we needed a system that just doesn't hear you, but it actually understands the urgency for us and kind of calms the human and offers a reassurance in more of a human form and feeds any critical or structured data directly into our workflow so that it can be handled accordingly. And this is done by integrating Amazon Connect for call center handling and Kinesis and Transcribe for the real time speech transcription, Comprehend for intent and sentiment analysis, and also Bedrock for smart AI generation of text, and converting that text into audio again will be our Poly. And this will bridge the emotional and informational gaps that we want in our emergency response. So I'm just gonna play an audio that we did record for our project. So this is where I kind of have like a workflow when someone is actually in need or who's actually in need of dire help. This is how it kind of solves.
Help, I crashed my car and my daughter.
I'm your emergency dispatch assistant. Are you and your daughter conscious and able to speak?
Yes, I'm awake but bleeding my leg and head. My daughter is unconscious and unresponsive. I'm so scared.
Stay calm, apply firm pressure to your bleeding wounds and keep your head still. Help is on the way immediately. What's your exact location?
We are at 456 Oak Avenue in front of some blue house.
Copy that. Paramedics are en route and will arrive in under 5 minutes. Continue firm pressure on your wounds, don't move your daughter, and stay on the line.
Got it, hurry.
You're doing great. I'll stay with you until help arrives.
So this is like the generalized workflow. Although it takes a few seconds, there is some gap. That is what we are trying to like further achieve. The trying to lessen that delay. And there can be a few corner cases in here where there can be code words used instead of saying, okay, I need help. For example, the very common thing is, I want to order a pizza. And that's not actually a pizza. Like a lot of emergency systems should actually understand that, okay, they are actually in trouble, but you need to understand if they're actually in trouble or if it's just a prank call. That is one of the other use case that we are trying to solve, and we had to like put in some code words into our model so that it can understand that, oh, like if it's actually trying to order a pizza or how it's going to work. So this is the other corner case workflow that we were trying to solve.
I would like to order a pizza.
Pizza? This is an emergency assistance. Are you in any sort of danger?
Yes.
Roger that. Pizza protocol engaged. First, what's your current location?
I'm at 123 Maple Street, apartment 4B.
Copy. Dispatching Unit Alpha to 123 Maple Street ETA 5 minutes. Anything else I can coordinate?
No, that's all. Thank you.
Unit Alpha is en route. Stay safe. I'll keep you posted.
So this is just a sample workflow of another where you can use a code word and kind of analyze. And another thing over here you can see is the response from the user will be very short. They won't be very descriptive, and they will try to be calm in this situation as well, because they're trying to have that whole pretense. So there is a slight balance between the two. That is something that you have to kind of improve in your model and try to understand that as well. So, moving on today, I will be going through a few services that fits into this flow, and walk you through what they exactly are. And at the end, I'll talk about a few architectures that I kind of made before I came on to the solution that I have today. First, let's talk about Amazon Connect. This is basically our contact center in AWS, and this is completely managed by AWS, and it is serverless. Kind of like a phone system powerhouse, no racks, no PBX, just pure cloud magic that handles all the incoming calls for you. And this is not only for incoming call, although our use case for incoming call was there, but you can do an outgoing call, a video call, email, chat, anything that you want. You can go ahead and you can claim your number, or you can port a number and you can use it however you want to use it. And it directly fits into your AI pipeline that you want to build, and responses can be put in right back to the caller pretty easily. And it also has skills based routing, so calls get sent exactly where they need to go, whether it's an agent or your AI lambda, wherever it needs to get routed. It's easily uh, plugged, and you can actually play around it. Also, one thing to keep in mind is every call is recorded automatically for compliance and analysis. This is part of the AWS structure. Because of this, you get real time dashboards and historic reports very easily. And this also has pretty good voice quality, as we heard. It was a normal mobile incoming call, the quality was pretty good. Although there was a little bit of disturbance, but it was pretty easy. So, how does this exactly work? You just log into your AWS, grab a phone number in less than a minute. There is no hardware, there is no telecom contracts needed over here. Next, you build your contact flow by dragging and dropping blocks for menus, data lookups, and routing. It's basically like snapping Lego pieces all together. You can just drag and drop your routes, your services, whatever you want to build it. And if you want to have agents by skills or languages, Connect automatically sends those callers to the right persons or the self service option, and however you have routed that. And these agents also have a very simple browser with caller info and call contracts, so that they can actually control the call that they're going to have. So, when I was going to Connect, I did go through other similar services that are out there. One was Twilio Flex, which is programmable and developer friendly, but you still kind of need to wire up the telephone part, the media streams as well. Although Genesis Cloud has a really rich agentic UX and a very advanced workflow, but comes with per seat fees, and it has its own AI models rather than direct hooks to your existing AWS workflows. With Connect, you are just live in minutes, pay per minute, pay per request, no seat license or long term commitments are needed. It is not available in all the regions, and this is PCI and HIPAA compliant, so that's a good thing. And it can scale from one concurrent call to tens of thousands without any architectural changes. That's one good thing with Connect and any AWS service for that matter. How does this exactly fit into the Swift 8? We needed a telephony front door that streams audio seamlessly into our AI pipeline, and Connect does exactly that. Connect starts logging the caller ID and timestamp, so we never lose track of who called or when. And this particular thing is very important for us to understand and keep track of whoever called us. Next, in the contact flow, we kind of drop in a start media streaming block, which under the cover opens a WebSocket and slices the caller audio into 20 millisecond PCM snippets, basically firing them into a stream, that is a transportation layer, where it can send through each fragment in smaller chunks and wherever it has to go to. In our case, it was a lambda, which had the more business logic for us. It can easily travel like that. And if we ever need a live agent fallback, we just have to tweak the routing block so no heavy re architecture is needed. That's about Amazon Connect in a nutshell. Like, it has instant setup, built in AI integrations, pay as you go pricing, and there is all the compliance bells and whistles out there. It's pretty easy to handle, but um, integrating with other services was one challenge that we had. That is something that I'm going to talk about later in the architecture stage. Now, moving on to Kinesis, it's an always on data stream service. Think of it as like a transportation system, a very big super highway built for hundreds of thousands of tiny payloads that can travel or that can take payloads for every second. Whether you're moving click streams, logs, or live audio fragments in our case, Kinesis can scale up and down automatically and retains data up to like 300 plus hours. And it can hand off to any number of customers without actually having any delay anywhere. That was pretty important for us in our use case. So, how does this exactly work? On the left side, we've got our live audio snippets coming from Amazon Connect media streaming in our case. Maybe like 20 millisecond bytes of what the caller is saying at a time will come as a chunk, and those get shoved directly into the Kinesis data stream, which is basically our highway for audio data. This is then sharded, ordered, and stored just long enough for us to use because this is just a transportation system. So that's about it. In the middle lane, we fan that stream out to whoever needs it. So maybe it's a Kinesis data analytics job that is running maybe like a SQL query, or even any heavy duty processing. In our case, it was a Lambda function that can just spin up in milliseconds for any real time transcription that we need at the end. And finally, on the right side, the cleaned up, enriched records flow out to wherever we kind of want them. For again, in our use case, it was empathetic response in near real time. So that was our use case. Um, all in all, it takes live audio in, and Kinesis does the core storage and ordering for a little bit, and it can have multiple consumers doing their thing and process data right outside and turning that raw emergency call audio in size in like blink of an eye. Coming to other alternatives, we did consider other options. For instance, the MSK, which is managed by Kafka, it has a ton of ecosystem goodies, but it's kind of heavier to stand up. All the SQS SNS is great for one-off messages, but not for churning through a continuous flood of audio. The self-managed Kafka gives a lot of control, but there is endless ops work to it. Honestly, Kinesis just sort of fits into our use case because it is easily connectable to Lambda, DynamoDB, or Bedrock, or anything that you want to have, and it guarantees the audio chunks stay in order with the shard level sequencing. And if you ever want to rewind or reprocess any window you need, you can always do that. And each consumer gets their own dedicated pipe, so our AI never gets stuck waiting for data. And best of all, there's zero cluster ops, no brokers to patch, no maintenance headaches. So Kinesis was kind of easy to integrate with Connect in that regards. It's basically you flip on the media streaming service in our Connect flow that rips off the raw PCM audio off the call and fires it straight into the Kinesis stream. Next, what we did in our use case was for our Lambda function, we added a trigger for with respect to the kinesis. So whenever there is a data stream that streams on any fragment streams on the kinesis, there is a lambda function that will trigger, and this lambda function fans the audio out to transcribe bedrock in the later stages that I'm going to talk about. That's pretty much it about kinesis as an introductory piece. Let's talk about transcribe now. This is basically speech to text engine which captures every utterance in your calls and converts it into accurate timestamp text. This can either be in real time or in batch modes. For us, it in our use case, it was real time because it was for emergency calls. But if you ever want to do like a nightly batch mode by running a cron job every night and processing the audio, it can also be done. That is a very valid use case as well. So how does this exactly work? First up, we are dumping the raw call byte state into the transcribe. You can either do it through real time or the batch mode, but it's the streaming API is the same, and it gives instant results just by um, just it does actually give instant results for both batch and the real time. Next, the AWS neural ASR pipeline that kicks in has something called as GPU powered acoustic models that turn these tiny chunks of audio into phonemes. And while this language model stitch those into like actual words and phrases, they are also tuned up for speed. And almost instantly, you get back the text plus metadata, word level timestamps, confidence scores, speaker labels, punctuation, even alternate guesses when it's not very sure. That is ready to feed directly into dashboard or your Lambda or anywhere, even compliance checks as well. And if you need to tweak for your use case, you can load in custom vocabularies for any jargon or acronyms, or you can even filter out sensitive terms and fine tune the spot on accuracy. For our use case, it was something like emergency, fire, earthquake. Those were our key sensitive terms. And in milliseconds, your audio transforms into actionable text. This is what fuels the Swift 8 smarts for us. Um, in our speech to text face off, Amazon Transcribe wins like hands down for us because it plugs straight into Connect, Lambda, and Comprehend, and it offers real time streaming and batch if we ever wanted all in one API. But the Google Solid, actually, it is quite solid, but it needs the custom connectors. And Azure splits the real time and batch into different APIs, which adds a little bit of complexity, but it's still doable. And if you ever self host the Whisper, eh, you kind of get full control, but it would have a lot of ops work. uh, so the transcribe actually has like seamless integration with no hassle for scaling. For us, it was kind of a clear choice. So we spoke about kinesis and we spoke about transcribe. Why do you need both together? In simple terms, kinesis handles the transportation. It orders, replays, and it can have multiple consumer delivery. Transcribe handles the heavy lifting of the converted audio, that is from audio to text. And with Kinesis in front, you can pipe the same call audio simultaneously into transcribe for transcripts and then later on to whatever you want to do with that particular data. um, and another important thing is that if you ever want to rerun your transcripts with a say you want to reanalyze a sentiment if something went wrong, or you want to do a report on something, you can always rewind a Kinesis stream. But transcribe itself doesn't retain past audio, but Kinesis actually does. So that's a pretty good use case for us. Now, moving on to comprehend. Comprehend is, think of it as like a built-in text detective. You feed like chunk of text, maybe like tweets, documents. In our use case, it was a call transcript that came from the transcribe, and it returns a few parameters starting with sentiment. So you know if someone is calm or panicked, it kind of returns a score. And then there is entities like name, place, medical terms, location. And then there is language detection in case where callers switch language and there's a live agent waiting, you can directly understand which language they are speaking in. And key phrases to surface the important bits, that if you want to ever extract important things or if you want to customize anything to actually look for. And all of this returns in like a JSON, so there is no manual tagging required for it. And yeah, so how does it work? Under the hood, comprehend tokenizes your text and runs a pre-trained ML models, maybe multiple models for both sentiment and entity recognition. And on top of it, it applies the language and topic models, then bundles everything into a response. But you call only one API where you drop in your text and it pops out a structured data where it gives out scores for sentiment, entity lists, and key phrases that it extracted out, language codes, and the topic confidences. This is also fully managed and auto scale. So whether you're having a handful of messages or millions of transcripts at a time, you don't have to touch any service. Comprehend kind of handles it. So that's a good thing. So how does this fit into Swift 8 for us? Um, as I played a few audio scripts in the beginning, it kind of gives us a few parameters that we can put into our bedrock model, so our prompt can be a little lean. That was one of our first use case for using comprehend. And we can also understand what exactly and it can analyze the text better, and it does have some sort of predictability. Rather, when you use an AI, it's a lot of free form. And when the output matters so much, it's better to have another layer of analysis along with bedrock. So moving on to Amazon Lex, this is basically a fully managed service for creating a conversational interfaces. It can be voice or text. Under the hood, this uses automatic speech recognition to turn audio into text, and then uses the natural language understanding to figure out what exactly the user means here. So, how does this exactly work? Here, there are a few components that you need to set up. The starting with intent, you tell Lex what things your bot can do. For example, if it wants to book a flight or order a pizza, in our case, it was a triage intent. And you add in sample phrases what users might say for each intent, like I need a ride, or you want to book a flight to New York, or there's a fire at Fifth Avenue. And for each of these intent, list out the pieces of information that you might actually need, like maybe uh, date or time for a flight, or any location. And if you have any emergency, you might want to have a severity also defined to understand, okay, what is severity level, so that you can actually kind of uh, give a score for all the emergencies, and you can kind of have a queue along with that. But yeah, we'll come later to that. Yeah, Lex will automatically prompt to fill in all these missing slots. And once all these slots are connected, Lex can kind of hand off the structured data to any Lambda function or any other backend in your use case to actually perform any action, like, for example, if you're booking a flight or placing an order, or in our case, it was triggering our use case. the flow. You basically flip on enable voice and text in the console. It is pretty easy to spin up the ML models for Lex uh, along with intent classification, and it kind of takes care of all the ML lifting, recognize the speech, and you can focus on actually doing your logic part, and defining your bot's personality and the business logic and the integrations is more important here, so we focused a little more on that. But how does Lex work exactly in our use case? In So the bot's main job is to triage emergencies. So we created a triage intent that represents, hey, I need help with an emergency. Once someone triggers that intent, we need specifics like emergency type, is it fire, medical, accident, or any other thing, and what is the location that's important for us, street address or intersection, anything. And severity is like critical, non-critical, immediate help. And we use them in, like, say users say there's a car crash on M street, pretty bad, right? And Lex matches this intent to triage intent and start filling the slots automatically. And if a slot is missing, Lex prompts the user. Once all these slots are filled, it hands off with the structured data. But in so answering the question, do we really need Lex? Because it can only do a fixed number of slots, and you have to manually add in all these slots. So how many slots can you possibly add? That is a question that we had to answer in between when I was integrating Lex in my use case. But you can actually use Lex dynamically by integrating these slots with, again, another Bedrock call, which will trigger a dynamic response. But that does add a layer of complexity. That is one thing that we noticed. Now, we've been talking about Bedrock quite a bit. Now, let's kick things off with the big picture, the Amazon Bedrock, which is basically a serverless API for GenAI. Think of it as like a magic vending machine for foundational models. You choose your flavor, push a prompt, and it pops out a text or any other form of output, maybe even an image or embeddings. And this is all without ever touching any piece of code or worrying about infrastructure. The process is pretty simple. You pick out your foundational model. It is very interactive, and you have a playground where you can test out the prompts for each of your use case, so you can kind of understand what is the best fit for for your application. You have a number of models to choose from, like there is Titan, Text, Claude, Llama, and then Jurassic. And then next you use your now if you want to add a bit of control, Bedrock supports this by, like, kind of fine tuning, or if you want to add a little bit of prompt tuning, you can do that. And you can call the Bedrock API with your system and your user messages, and the Bedrock routes its model endpoint and spins up like the right amount of compute that is needed and runs the inference for you. And all of this is in just a few milliseconds and gives back a JSON payload, and it contains the output in form of text, embeddings, or images, or however you asked it to do it. And all of this is in like 5 steps, and you can always choose to tweak your model with your prompt, or if you want to add an additional layer of model for your use case, you can do that. And that's what we are going to discuss over here for a bit. You can hook Bedrock up with your own data stores. Say if you want to add like a SD bucket database or your own custom knowledge base. And you can do this by enabling the retrieval augmented generation hook. And Bedrock automatically ingests all these information and indexes this and retrieves the relevant documents to layer this extra context on your prompts. This means that you will have a little bit more accurate, up to date answers without you actually having to build your own search pipeline. And because Bedrock has context of the last few turns of conversation that you have automatically, you don't actually have to stitch the history together. The service maintains the session context, so your chatbot kind of feels natural and a- actually remembers what you said in that particular context. So it's a good thing actually. And if you want to use RAG, you can Bedrock can include like footnotes or citations here, and like along with the your answer. This kind of boosts like the trust and transparency when you actually know where it came from, especially if it's a large document or any sensitive data source. So all in all, Bedrock is like end-to-end Gen AI platform that manages the retrieval, context, security, and also scaling, of course, so that you can actually focus on prompt building. And if you want to add like a custom model, you can do that as well. So how does this fit into our idea? So think of it as like a AI sidekick for us. Once transcribe spits out the text and comprehend tags it with sentimental scores and indices, we kind of bundle that context and toss it back at Bedrock. We chose the Anthropic Claude, that was for our use case. It kind of figures out the emergency like fire, medical, or whatever, and even suggests the next steps. So our lambda isn't just about the collecting the data, but actually reasoning it. And if you want, like, we added a few strokes of like be calm and helpful in the prompt so that Bedrock actually sends in like a warm human sounding reply, and we fed that into Poly directly, and from Poly it went to Connect, and that's how it kept flowing. But I will talk about this in a little while. But basically, Bedrock's the brain that understands what's happening and crafts the right empathetic response until the help arrives. So the question comes even for need game. Did I really need comprehend in my use case? Because I could lean uh, onto my LLM to suss out emergency, the location, the emotions, if I crack the prompt that I want to have. But comprehend makes my life a little easier, and I'll tell you how. It's lightning fast and it's consistent. And every call, every time you get sentimental scores, entities attached with it in a few seconds, milliseconds. There are no surprises here. As I said before, the upfront structure of the LLM prompt stays lean, focus purely on just the empathy and the next step logic. Because having these discrete emotion tags, panic, calm, and the location fields, it kind of gives us clear metric without having to wrestling with the freeform AI output that we don't have control of whatsoever. And it is cost effective than piling up extra models on Bedrock when you compare it in that way. And it does add in that little bit of predictability, and it is quite fast, and cost control really pays off here for us. So comprehend is something that it was a good choice for me to use it over here. Now let's talk about Poly. It's basically AWS's text to speech service that turns the plain text into lifelike audio. It's a flip side of transcribe instead of speech to text, it does text to speech in different accents and different languages. This uses deep neural networks under the hood, so the voices seem really natural, no more robotic or monotone drones. And you get options ranging from warm conversational voices to more formal as well, and you can change it very quickly. One cool trick here is the SSML support that we use, that is speech synthesis markup language. You can add pauses, emphasize certain words, adjust the pitch, or even insert sound effects in line with your text. And adding this soft tone kind of give comforts to the end user with respect to instructions, or if you want to speed up a little bit with respect to if the caller is in a hurry, all this can be done without actually manually having to edit it. And Poly does stream in real time audio, so you don't have to wait until the entire file is generated. So you can set up directly to connect. So that was a pretty good thing for us, so that we don't have to waste time over there. And of course, it has a pay as you go by character or second of audio module, and it scales up and down as you need. Uh, that's pretty much about Poly, and let's see how it plugs into action in our use case. At the end of our pipeline, it after the Bedrock's empathetic response is out is is outside, we feed that directly into Poly, and we use the SSML tags because we want some little bit of empathy added by Poly as well, so that it calms down the end user. And this streams directly back into the connect, completing that journey. So we start from voice and then text and then AI and then back to voice, so we kind of loop from here. That's pretty much about Poly. Now coming to X-ray, let's uh, if so because there were so many things happening in our one single lambda, we wanted a little bit microscopic version of what exactly is happening in the code and what's happening under the hood. And X-ray was it. Even CloudWatch does it, but we I wanted to do it with X-ray this time. You just write your code, deploy it as usual, and you can directly hook up with X-ray. There is no SDKs needed for this. Once the tracing is on, X-ray automatically kind of records these segments for every invocation. That means like each time your function runs, X-ray captures the timing, the metadata, and any downstream calls that happens for any AWS service. And these get fed into the service map behind this map is a list of execution details, and you can click on any node, say a DynamoDB call, and you can get a timeline view of showing how long each operation took, any errors thrown, even user defined annotations if it's injected. So the root cause analysis was way easier over here. And in our particular use case, it was like end to end visibility for our Lambda invocation from start to finish. And it's easier because we know the root cause, and it help to debug, optimize also a little bit, and it was quite reliable as well. Now coming to the architecture part, there are these are more on event driven scale. There are three solutions that I tried out, each one advancing than the other. I will talk about the offline batch first, where I kind of recorded the calls first. So this happens after the call is disconnected, where the calls are recorded and they are stored in S3. And this happens after the call is recorded. So the process is quick after the call finishes, and it's a little bit more cost efficient because we can skip the live streaming, and all of this can happen in under a minute. So how this workflow works is, so every time someone calls into Swift 8, we are recording that whole conversation, dropping the audio right into the S3 buckets. For example, it was in that was another call recordings directory. So the moment that file shows up, S3 triggers like a tiny lambda function which kind of kicks off our step function workflow. So no, so we did not wait for a nightly cron job. We wanted to do as it arrived, as the calls arrived in our use case particularly. And once the step function picks up the job, the first thing it does is fire off a batch transcription with Amazon Transcribe, and you point this new recording um, at maybe a minute or two later, and Transcribe drops back this JSON into the transcribe directory. That in turn triggers a S3 event that would have our business logic lambda, and inside this lambda it's like that is the sentiment, entities, comprehend, bedrock, and all the future stuffs, and that would again put into another S3 enriched directory. So in under a minute I went from having a raw audio to fully tagged analyzed call data without having to have a live streaming setup. Although this is simple to maintain, it does scale. Um, but you're looking at something that is like seconds to a minute delay, which is kind of okay for reporting and analytics, but not for a back and forth conversation because you would have to call back that person, and that's not the most ideal way to do it. And that comes to my second solution, that is the lex driven bot. And this is like an end-to-end fully automated voice bot that greets the callers, captures the critical details, and decides whether to route them to a human dispatcher or continue giving assistant via the AI. That is something that Lex kind of that is something that you we were like I was trying to achieve over here. Say the use case is pretty simple. Say someone calls the support line and Connect obviously grabs the basics, the caller ID, timestamp, and everything. Then we funnel this live audio into Lex, which um, uses the built-in ASR and NLU to both transcribe the speech and map it into the predefined intents and slots that we discussed earlier. And since I did it with configuring this with emergency intent slot type, so you would have slots like location, severity, emergency type. So when someone says I need help, there's a fire, Lex instantly tags fire as an emergency type and start filling the other slots without having to hand code anything over here. And at any point of time, say if Lex isn't confident about a slot value, say it's says like M street, just M street, nothing else, and it cannot geocode over there, it kind of pauses, and you can have a validation lambda where it can trigger um where it can check if the street name actually exists, and it can either move on or follow up like, sorry, I didn't catch the street and city, mind repeating that. Lex only re-asks this missing bit, so caller doesn't have to repeat the entire conversation again. And once every slot is confirmed and all the inputs are in place, Lex will fire the fulfillment lambda, that is the business logic where we have the bedrock call analysis and everything, and sends back the JSON back to the Lex. And Lex in turn will call Poly for us, which will generate the audio and Connect plays it. So here we don't have to actually call Polly on our own, it would be by Lex. So Lex would do the heavy lifting for us over here. That comes to my next and the final architecture that I have today is the kinesis driven flow, where where you can stream the raw call audio straight into the Kinesis, and you will see send like transcripts and sentiments pop up live. So no more waiting for the Lexus black block box where you can do only limited things with Lexbot, and you can only get limited number of inputs and outputs from Lexbox. And over here everything kind of zips into the Bedrock's LLM, so the bot can roll with unexpected replies instead of actually crashing on unknown slots in Lex. And we ditched the heavyweight validation lambda so that our model kind of can run smoothly. And because Kinesis fans out to transcribe, it can it can actually scale. There is no more throttling, no more surprise, no more lex bill. So we took out the entire lex part over here, and you can tweak the conversation mid flight. If you want to have like new questions or change the tone, you can redefine every single slot instead of having a static slot like we had in lex. So here's how it all comes together in real time. The moment someone calls our connect number, we fire up a tight loop of audio streaming where AI processes and responses all inside one lambda. So things happen in under a second over here. First, connect start media. Streaming block grabs that every tiny PCM fragment of the caller's voice and pushes it into a Kinesis data stream. Um, Kinesis, think of like because Kinesis would order each fragment with low latency, and it can hold pieces up to like 24 hours, or you can even rewind as well. This would basically trigger our orchestrator lambda, whether it's every 100 milliseconds or even 100 records. It doesn't matter. It can scale as you go. The this function kind of gets the Kinesis newest batch of audio, stitches these fragments into words, and kicks off the downstream magic. Inside the same lambda, we open a transcribe streaming client. Um, you we kind of do transcripts right away instead of the batch mode, and the final transcript events whenever someone has a pause in the audio, so you don't have to wait for S3 to trigger in the code uh, or anything. And soon as we get the output from transcript, it's taken right back to the comprehend. With each completed utterance, we call comprehend to tag sentiment. Either it can be positive, neutral, or negative, and you can pull out entities like street names or medical terms, and then you write your enriched line like text with timestamp, sentiment, entities into your, say you want to store it somewhere like DynamoDB. This actually gives us two important things, like a sliding window kind of context, so our LLM knows the last few lines, even though it doesn't have to, but it's a personal preference on how well you want the prompt to be. And also a permanent audit log for future analytics, and if you ever want to train your model, you can always do it with that. Then we package up the recent dialogue and sprinkle in like little bit of calm and empathy into the prompt, and then run the Bedrock Anthropic Claude. In like few milliseconds, we get a thoughtful response tailored to the caller's request. Finally, with this response, we hand that text to the poly in the SSML mode, so we can add like little bit of pauses or emphasis, and it grabs this audio stream and feeds it back into the Connect's play prompt block. Now Connect then has to loop back in the in like get customer input again, so that there's a conversation happening, and again it streams the uh, PCM frames and the cycle repeats. And that's how we can deliver like a two-way AI conversation that is like kind of fast, reliable, and also you can tweak it how much ever you want to. Now, coming to the question of like how do you keep each conversation in its own lane, um, or concurrency. So this is via contact ID that is generated via Connect. So when Connect streams the PCM audio into Kinesis, we use Connect ID as the partition key. That way, every little audio fragment for say call A goes into one shard, and every piece for call B goes into another. So there is no heavy traffic that where audio can get mixed up. Then our kinesis triggered lambda only ever sees record for one contact ID at a time. It reads that ID right of the record holder and then stitches the audio into utterances and then sends them to transcribe and then comprehend. And with the same ID, it logs into the database as well. So every action is tagged with this caller ID, and I mean the contact ID. So the and when the poly cooks up this SSML response, we call the update contract attributes with the same contact ID and said something like the next prompt is this, and inside our connect flow the play prompt block grabs this attribute and plays the audio right back to the caller, so there is no manual routing needed anywhere. So with this contact ID partitioning in Kinesis, metadata carried through each lambda and the call scoped tables that is happening in DynamoDB, the attribute based playbacks and connect and Swift can handle like dozens or hundreds of emergencies in parallel without ever mixing up a single voice. So that was pretty much about the workflow of Swiftaid. This is something that I'm still trying to improvise. There are scope for improvements. There are so many corner cases that you can handle. There are things that you can think out of the box and you can stitch in more components together. So this is still like we built three versions of architectures already that and I'm thinking that there would be one more. So yeah, this is pretty much about Swift 8. If Thank you for today, but if anyone has any questions, I'm happy to answer.
Okay, so yeah, so we have a couple of questions. Rashmi, I'll just put it on the channel, sorry, on the screen, assuming it's visible for you. Do you need to train it for cases like pizza, or is it smart enough to understand other code words?
No, you need to train it because pizza is something that is quite common and it may not understand. Say, it can be a prank call as well, or it can be a call by mistake also. So anything can happen. That is something that you, as I said, it has to be a slight balance between like actually understanding what the intent is and the text of that intent as well.
Got it, got it. So one more question is what would be the cost for building an application like this, especially given that there are so many components involved? So what is the cost implication? I know almost all of them or all of them are serverless in nature, so it's
Yeah,
generally
all
pay
of
as
them
you.
are serverless. So it's
Yeah,
mostly how you hook onto it. Because for our use case, it was more of a personal project. It was like pay as you go model was the easiest one. Uh, I don't. It shouldn't be costly because Bedrock calls are also pretty cheap. Um, so I think the pay as go model is like the best fit.
got it, got it. So one more question from my side is yeah, I think you pretty much covered that as well with different options that you had in your architecture. One is this entire conversation that you were trying to build is very time sensitive, right? Because you
Yep.
have to respond as
Yep.
early as possible,
Mhm.
almost instantly. So given that there are so many components in your architecture, latency is again at every point in place, right, of your architecture. So did you do anything, and did you measure what is the overall response time from the moment a caller called and the dispatcher, the AI agent, is responding?
So that is something that is where the next improvisation comes in, because our transcribed and comprehend kicks in only when the user stops. So it kind of needs the entire context rather than having every single word, and that would take a few milliseconds after the user has stopped speaking. That would take like 1 or 2 seconds. Even now there's a gap where I played the audio, like there'll be like a 1 or 2 second gap. That is something that we are trying to solve, where you can have like because it's a sequence of job and you cannot skip going from one job to another, and you cannot do parallelly. You need the previous job's input to the next one. That's where the time sensitivity comes in. I was figuring out if I can use step functions, but even to do it parallelly I need the previous
Yeah.
output. So yeah.
Yeah, I think that's a really interesting problem to solve.
Yep.
So thank you so much, Rashmi. I mean, you covered a lot of services, a lot of AI serverless services. It was great to see how you stitched all of them together to solve a critical problem. So Dharmendra, do you have any questions?
Yeah, just one last question from mine. Like, there are so many services you integrated. So, I'm interested to see like how did you integrated it, like with the infrastructure as code, or some services as infrastructure as code, or some manually integration. How you integrated
It
all these?
was mostly infrastructure as code itself, but some of them, like where it came to connect, it's more like plug and play sort of thing, which is still connect was the most challenging part, because integrating that with the entire flow where you have to loop back the response,
Mhm.
and you need to understand where you have to disconnect the call if you need to disconnect as well. So that is something that was a little bit challenging. So we kind of did like a drag and drop over there, which was pretty simple. And integrating that with like lex also with that particular slot and understanding the intent also, and like integrating that part was also quite challenging. So it was like a mix of both for us.
Got it. And one last question from my side. I mean, in real world cases, there will be a lot of bogus calls, prank
Yep.
calls, and stuff like that. I think that is where AI can probably kick in even more than the actual responding, because actual responding will require coordinating with a lot of different
Yep.
teams, different services in real world, not the AWS services, right? So I think AI would be perfect fit to try and filter out the actual call so that can go to the right person and take action.
Yep.
So I'm assuming that's one thing that you will also be working on next.
Yeah, that's one of the things. And the major use case is, say there's an earthquake and there are hundreds of calls. Who do
Mhm.
you cater first to? So you have to build in like a score analysis system where you score each call, and then you would store the most important metadata that we're storing already in the DB right now, and then kind of trigger a queuing system. But that is also quite risky with the balance that you need to understand. Make sure that the data that you're storing is actually very relevant and is reliable. So that is the next part of the project, where uh, you can handle multiple concurrent calls, and you can add in like a queuing system, and how they can dispatch or take any actions, and focus on the most immediate ones that they have.
Awesome. That sounds really interesting, and we look forward to this second part of your application.
Yeah.
So thank you once again, Rashmi, for joining us so late, all the way from the US, and it was really insightful and a great use case that you wanted to try and solve. And thank you for all the insights. Thank you so much once again.
Thank you,
Thank
Rashmi.
you.
Thank you.
Thank you.
Okay, so that was a really insightful session. And yes, we are not done yet. We have the next session from Daria. So I'm just adding her to the stage. Hey, hi, hello, how are you doing?
Hi everyone. I'm good. Thank you. How are you?
All good. So one speaker was joining us from the US, which is very late for her, and then we have the other speaker who's joining early in the morning. So thank you, Daria, for joining us early in the morning.
Uh,
So we hope you have a great time, and of course our audience is well listening to you. So
okay.
yep.
Yeah, thank you for inviting me. Yeah, it's 8:30 a.m. here, and I hope I will be not so sleepy. So let me share my screen.
Yes.
Okay, just a moment. And um, yep, I hope you can see it,
Yes.
right? Yeah, so I can present. So today my
Yes.
session is about how to build an Amazon Bedrock agent for document processing. And this is will be like a step-by-step guide because actually we can build a document processing agent like in layered fashion. So let's dive in. And I wanted to start this session from the quote from Andrew Ng, who is like a famous person in a field of AI and a field of Gen AI. And he said, I think AI agentic workflows will drive massive AI progress this year, perhaps even more than the next generation of foundation models. So, to be fair and to be honest, this quote was about last year, but I feel that this is still actual about current year because we can see that we can see new models, we can still see new models coming up, but more and more people and researchers are focused on agentic workflows because this is something that can execute actions and can act independently. So let's dive in. Today, our agenda is to first introduce Bedrock Agent. Then we will think about what will make a good document processing agent and how we can speed up daily tasks. And then we will dive into how to build a document processing Bedrock agent, how to create agent, how to add action groups, how to create and add a knowledge base. And also I will be showing you common errors which you can encounter while building the agent because not all of these errors are kind of intuitive, so you can be stuck on them. And also, I wanted to share some considerations and limitations and what you would like to do next. Okay, and we will have a Q&A, so prepare your questions. I will be happy to hear them. First, a quick introduction of me. My name is Daria, and I'm a AWS community builder since 2022. And now I'm in the AI engineering category. Previously, I was in machine learning category. I'm 7 times AWS certified, and I just like learning and sharing my knowledge. So let me introduce Bedrock agents. But first, let's talk about Amazon Bedrock. Uh, Amazon Bedrock is a fully managed service with a vast choice of high-performance foundation models. So it is serverless service. It means that you don't need to think about how to deploy your models, how to, I don't know, host them. You don't need to bother. You can access these models via a single API, and you can work with them. You can call them, integrate into your application. You can experiment, evaluate, privately customize these models, and there are a lot of like a whole model zoo available there. You can experiment and choose the right model for your use case. So this is perfect to start with many AI models, foundation models, and because you don't need to care about infrastructure. So this is covered, and security is also covered for you. And I also wanted to share, like many companies, they saw the benefit of Bedrock and they decided to adopt the service. One famous company, Ferrari, they offer, if you want to buy a Ferrari, they offer a lot of customization. You can select a color of your interior, you can select type of your wheels, and so on and so forth. So you can imagine how many possible configurations like possible are available there. So they developed kind of 3D constructor where they integrated um, models from Bedrock, and also they fine-tuned Amazon Titan, Llama, and also I believe Claude model to with their data to provide a more enhanced customer chatbot support. So yeah, pretty interesting use case. And let's move to Bedrock agent. First, let's define an agent. What is an agent? Yeah, because we kind of can understand intuitively, but let's define it first. So an agent is an orchestrational software that guides the workflows between user requests, foundation model, external data sources, and applications. So what does it mean? This means that this is piece of software can orchestrate and guide and decide how and when and what to execute. That makes it smart and capable to accomplish different actions. And if you're curious, you can go to Amazon blogs and read how does it work under the hood. But in short, it uses React reasoning technique. A React is shortened from reasoning and action. So it has a predefined prepended instructions, aka system prompt, which can kind of set in the stage given the role to the agent. For example, you an AI smart document assistant, and so on and so forth. So agent can understand how it should act, and all this orchestration uh, is accomplished by a foundation model. It serves as a reasoning engine, and it tried to accomplish a user-given task by step-by-step workflow. So what does it mean? If I ask an agent to process some documents, it will understand my request and try to break it down into several stages and try to execute them step by step. So the output of the first stage will become the input to the second stage. And by chaining them all together, it is trying to accomplish my task. So this is what is so powerful. This gives agent possibility to accomplish pretty complex tasks because it's just breaking down into steps and trying to execute them, and can, if for example one step fails, it can reiterate, it can try a different approach by trying to achieve and solve your task. And let's talk about document processing agent. What does it mean? If I have a bunch of documents, what would I like to do with these documents? Of course, I would like to summarize some documents because they can be very long, and I want to just know what's inside without too many details and without going into the document itself. Also, I would like to have kind of Q&A based on a document. I want to retrieve some information, just asking precise question, trying without going to the document and without trying to find it by myself. Also, if I have, for example, Excel spreadsheet and there are some data, I would like to have a simple analysis of such data. For example, maybe some average sales per month or some high level plot would be very useful to me to understand what is going on at a single view. And also I would like maybe to do some simple mechanic changes, content format. I would like to adjust it or change the representation of dates or something like that. So you can see examples on screenshots. So at the first one, I'm asking just a simple question about document content. The second example, I'm trying to alter sales dates to a different format because we have like years, months, date, and year, day, months. They are different to different countries, and we want to maybe change them sometimes. And this task is perfect for agent. I will show you in the demo because this is very like mechanic, monotonous work for a human, and that for sure can be automated. All right, we were talking about some simple tasks, but there are also advanced tasks we would like the agent to take care of. Or, for example, if we want to have some integration with other AWS services, like Textstruct, if we have PDFs and we want to extract like a form or pairs of fields and values. Or we have also Amazon Translate, and if we have multi-languages in our company or in our use case, and we want to translate from one language to another, so that would be nice. Also, we have databases inside AWS. Maybe we want to store something into a database or into storage. So this all is about integration with different AWS services. Also, we would like to have more complicated pipelines, so really complicated, like multi-step changes, multi-step task. Please parse this document with Textstruct, then translate it, then store it to the database. So this is also a task for the agent. Also, we probably would like to have a RAG-based search across documents. This is, if we want to do this, we need to set up a knowledge base to be able to have such kind of search. No, this is all our advanced task. And let me show you the architecture of the agent and show you how we can make sure that these actions can be accomplished by the agent. So first, this is maybe looking a little bit complicated. We will be seeing it layer by layer. So the first one, user is interacted with the agent itself. So user don't interact with any services underlying the agent. It is just they just chat with the agent via chat box. What gives the agent ability to execute different actions? It is by having an action group. Action group, it is something you can imagine that action group is a toolbox. So every time agent will need to execute some action, it will go to the toolbox and see what kind of tools it has. So it is a collection of APIs, and agent has these APIs, has its descriptions of such APIs, actions, or tools, and can select what is appropriate for the certain situation. So these APIs, their collection, they are living inside action group. So agent can refer to the action group and call these APIs. But the API code itself lives inside a Lambda action group Lambda function. So this probably, maybe it is Python functions that can be called as API, and they are different. For example, one function can interact with Amazon Translate, and just given some text or document path, can call Amazon Translate and translate the document. Another API or function inside our Lambda function can query or write to Amazon DynamoDB. One more can interact with Amazon Textstruct and extract some text. Similarly, one function can be for saving or retrieving documents to or from S3 bucket. So they are different. An agent can distinguish between them and can understand in what order to call which function. So this is our action group. This is our toolbox. And the next one is what is related to knowledge base. So if we have a collection of documents, we can maybe live in inside S3 bucket. Like here, we have some policies, we have some internal guides, internal rules, or we can store them to S3 bucket, and then we can create an Amazon OpenSearch serverless index. Essentially, this is a vector database. And based on this vector database, we can create a knowledge base, a Bedrock knowledge base, and then connect this knowledge base to the agent. An agent can query, so it can go to the knowledge base and search for relevant information. And I will show you how. So let's approach how to build a document processing Bedrock agent. And we will be building like layer by layer, step by step, because we can actually add some complexity to the agent, and you will see how. So first step is to create the agent itself. If you, of course, it can be done programmatically. So, but I've shown you how to do this via the console, because it just click and select something and input some values. So it is more like intuitive. So if you go to Amazon Bedrock console, if you choose Builder Tools Agents from the navigation pane, you can click Create Agent, and you will see such window, like Create Agent. You need to provide an agent name and optional some description just for your references. And you click Create, and essentially this is when your agent is created. It is already created. So it is just simple as that. And then you will be automatically redirected to the agent builder. Agent builder will open. Agent builder is just like more detailed level of settings for the Bedrock agent. And here you have a set of different settings. Maybe the most important setting here is to select the model. In my case, I selected Novalite. You can select Claude family models. It's up to you. A model is important because this is something that serves as a reasoning engine of the agent. So it's like has a direct influence on how your agent performs. Also, up to you, you can select a resource role. Otherwise, it is updated automatically. You may want to specify some instructions, as I was saying, to set up some stage and guide the agent specifically, and tell the agent about its role. And also we have additional settings like code interpreter and user input. What does it mean? For some tasks, code interpreter is very useful because it's enable agent to handle tasks that involves like writing, running, testing, and troubleshooting code in a secure environment. So if you, for example, ask an agent to analyze some data inside your Excel spreadsheet, that is probably the task for code interpreter. It's not the task for chatting with a document or having some Q&A based on the document. This requires to generate some code and to execute some code. That's why for such kind of task, code interpreter should be enabled. And user input, it is just for agent to have the ability to prompt additional information. So if the user maybe words the request in unclear fashion, agent can double check and specify what is required for this task. All right. So by just creating the agent and just selecting the model and saving the agent in the agent builder, you can already accomplish this basic task. So you can summarize documents, you can retrieve information, analyze data, generate plots, and make some changes to the document. So it's amazing. You didn't write a single piece of code. You didn't write anything yet, and you can already work with your documents. Of course, these tasks are pretty basic, but still you have such ability. And there are possible errors during this step, and some of them are misleading, I would say. So, for example, if you don't see any model you can select when you're trying to select the model for your agent, this is probably because you don't have any model access in your account enabled. So you need to go there and enable some model access inside your account. This error is very misleading. It is saying that overridden prompt that you provided is incorrectly formatted and so on and so forth. So you may think that maybe my prompt is not good enough, but what can be wrong from the prompt itself? This is because you asked to do something that that requires code interpreter, and code interpreter is just not enabled. This is just as simple as that, but the error message is misleading. And also very, very important, after you are doing any changes in Agent Builder, don't forget to prepare the agent. So you have a button, which is called Prepare. Don't forget to click on this button. Otherwise, your changes won't be applied to the agent. And let me show you a demo. For the sake of time, I recorded and edited demo a little bit. Let me just bring it here and show it to you. So you can see that I'm inside Bedrock console, and I just click create agent. I provided agent name. I provided a description, and also here I need to select the model. I will select, yes, I will select a Novolite model from Amazon. Also, I need to provide some instructions for the agent, and I'm providing, this is setting up the stage for the agent and tells the agent about its role. And then in additional settings, you will see actually the error that you saw on the screenshot because I forgot to enable code interpreter. It is disabled, but I enabled user input, so my agent can prompt the user for additional information. So I'm saving the agent, and you can see that this is small button about prepare the agent. You need to click it every time you do any changes inside your agent builder. And this is just showing, because I didn't create any role, I didn't select any role. So you can see that my permissions for using Novolite model was added automatically. So I am trying to test my agent. I can attach file to the chat from my local storage or from a S3 bucket. Let's pretend this is sample company report, and I'm asking about what is going on inside. And you can see that agent can summarize, or it can answer my dump question about the document. And here I'm trying to attach the file to the code interpreter, and I'm trying to have the analysis of sales data. And I have this error because I did not enable the code interpreter. And code interpreter is needed because for data analysis, it cannot be done just by calling the model itself. So I enable the code interpreter. I am saving it. Yes, I'm showing that I'm an enable code interpreter. I'm saving it, and I'm clicking prepare the agent. Otherwise, my changes won't be propagated to the agent. Yeah, kind of annoying. I need to attach file one more time, and I need to ask it one more time about my sales data. And what is nice, I can have like a high level overview of the data. Yeah, what is going on in my sales? How is it going? And using the same file, I want to change the format. Instead of using like classical format, year, months, date, I want to have American format like year, date, months. And you can see that I have like year, day, date, months format now in the newly generated file. So that was about, and you probably noticed that I did not write any code. I did not write any like API on how to analyze a document or how to or how to alter the date format. This was out of the box, and this is nice because it allows you to start quickly. So if you want to make your agent even more advanced, even more smart, you may want to create and add an action group. So as I already said, an action group is a toolbox that defines actions that agent can help the user perform. And we can have up to 20 action groups per agent. And this is simple. We need to go to the agent builder and we need to find action group and we need to click add and provide some details of the action group name and description. This is simple as that. Then we need to select an action group type. We can define it with function details, in a visual construction, or we can define it with API schemas if you have like a big YAML file, you can already upload it here, and your APIs would be defined by it. So if we go with the first option, if we provide in function details, we can provide them by just filling in the simple table, or just copy pasting the sorry, or just pasting the JSON file with the functions and their descriptions and parameters. And then you need to communicate to your agent how it would be able to execute these actions or call these APIs. So this is kind of connection between agent action group and Lambda function. So you can create a new Lambda function, you can select an existing Lambda function, or so for some workflows, you can select a return control. So agent will wait for the user to perform a certain action. In our case, we already have an existing prepared Lambda function, and you can select it and proceed. And this gives your agent ability to accomplish advanced tasks like communicating with AWS services and accomplish multi-step pipelines. There are like more errors are possible here because some of these errors would be linked to the Lambda function. For example, access denied while invoking Lambda function. You can see it here. Yeah, you need to add a resource-based policy statement on the Lambda itself. So the Lambda should know that the agent can execute this Lambda function. Or you can see such error that it was an error processing the Lambda response. Most probably that is because agent is expecting Lambda to have a specific output format. So it can find the relevant fields after calling the Lambda. So if you don't follow this format, you may see this error. Or maybe your Lambda is interacting, for example, when it's interacting with TextStruct, it requires some time to process the document. So it's not just like go and that's it. So you need to add some wait times to the Lambda. And you also need to increase the timeout, because if your timeout is too short, Lambda just fails and your document is not processed yet, and you don't see the expected output. So these are two possible causes of this kind of error. Let me show you a demo on how to add the how to add the action group. So we are inside our agent builder, and we are going all the way. Yeah, we are going all the way down, and we find action groups, and we click Add Action Group. We provide action group name, provide some description so agent can understand what it's about. We are selecting our action group Lambda function, and we are defining here, we're just providing kind of description of different action group functions. So one function is to extract text from PDF. We're using Amazon Textstruct to do this, and we're saving results to DynamoDB. And we need to provide parameters here. For example, we have S3 pass. This is passed to our PDF file. And we have a table name. This is name of DynamoDB table. These are two required parameters for this function. So the agent needs to know this beforehand, before calling the Lambda function API, so it can know what parameters to fill in. And similarly, you can define one more function. In that case, this is translate document function. When we are done with our functions, we click create. So our action group is created, and we save our agent, and we prepare the agent in the chat box, in the chat. And then we try to execute one of those APIs from the Lambda, from the action group. For example, we need to extract text from one file and update the specific table inside DynamoDB. And you can see that this was executed successfully. Text was extracted and the table was updated. But this is just an example. You can imagine that you can be very flexible with this kind of APIs, with these kind of actions. So last layer to our agent is how to create and add knowledge base. So if you go to the Bedrock console and you choose Builder Tools, Knowledge Bases from the navigation pane, and then you can create knowledge base with vector space. That would be the first option here. There are also two different knowledge base types, but we will be focusing on the knowledge base with vector store in our presentation. So when you are trying to create knowledge base, you need to specify. So the most important information is about what is your data source. And you need to provide this data source details. Of course, first you're providing name and description of your knowledge base. You may provide some AAM permissions, and then you are diving into your data source. So in our case, it was Amazon S3 bucket, pretty simple to provide it as a data source, but you can use a web crawler, you can use your custom data, and some third-party data sources. This is pretty flexible. Then when you already selected the type of your data source, you can configure it. So you provide a data source name, you provide its location, you provide a S3 URI, so it can be a specific file or it can be a specific folder. And then you provide a parsing strategy. So whether it's a default parser or foundation model as a parser. What does it mean? For example, if you have just texts, some textual data, maybe default parser is enough. But if you have some pictures, maybe advanced tables, so maybe foundation model would be more beneficial for you because you can incorporate this information from your images to your like a contextual information to your knowledge base. And then a chunking strategy. For experimenting, default chunking would be enough, but if you have a specific knowledge of how your data is organized, maybe it's organized by chapters or by some, I don't know, some piece of information per page, you would like to customize this chunking strategy. And then you need to select your vector database, like select where your vectors, like embedded data, would live in, and you need to select an embedded model. This is pretty, in that case, this is pretty, can be misleading, yeah, because you may select embedded model to which you don't have access to. So you need to check beforehand that you have access to it. And then you need to select a vector database. You can select Amazon's OpenSearch Serverless or other type of databases to store your embeddings inside. So then you can review and create your knowledge base. And a very important step is to synchronize your data sources. So your knowledge base is updated, and then you are selecting model to test. And you can test in different fashions. And you can see what is nice when you ask some information and you have the response, you have the link to the original data source. What does it mean? And where this data comes from, so you can track easily. And then, given that you are happy with the knowledge base, everything is okay, you are going to connect this knowledge base. You go back to the agent builder, you go to knowledge bases, and you click add, and you can add up to 2 associated knowledge bases per one agent. And then you can chat just casually with an agent. You don't need to indicate, please use a knowledge base. Agent will understand that maybe this information should be looked up inside the knowledge base. And that gives your agent the ability to search across knowledge base. So essentially, this is RAG-based search across different data sources. Yeah, I wanted to show one more demo here. I already created one knowledge base here, and I will show you how I would test it. I will select a model to chat with a knowledge base, and I will pass some question to the knowledge base. Yeah, and you can see that there is a toggle here, whether I want or I don't want to generate responses. What does it mean? I can have a coherent response from the model, or I can see what chunks, what pieces of documents I extracted. So it's up to you. And when I go back to the agent, I find in agent builder knowledge bases, I click add. I select in the correct knowledge base, add some description so agent can know what can be shown, what can be found inside. I am saving, I'm preparing the agent, and I am chatting with the agent, and it can query the knowledge base and retrieve the response. And you can see that it provides me an information and also shows me the data source, so I can go there and check whether it's accurate or not. So let me go to our next part, is to what to keep in mind when you build Bedrock agents and where you may want to go next. So because this AI is not deterministic, yeah, you need to have some considerations and important limitation in mind. Yeah, security is like the biggest concern nowadays, and you need to make sure that you have secure access to your APIs and data. Also, think about in user input. You need to validate and sanitize user input. Also think about who can access for what kind of workflows, what kind of agents. So you need to implement some access controls for agent management, for agent testing, given that you have different people who will be doing that. Also, as you can see, and maybe knowledge base or some kind of setups could be created in a wrong way. That's why we need to do a lot of testing and a lot of auditing to understand whether we can rely on the agent responses. For now, we can have text, so user can chat and we can upload some files. We cannot use voice out of the box as an input. Yeah, so you just need to keep that in mind. And maybe consider your workflow. Maybe it's not so complicated. You don't need to use some agents and AI. If you have very simple trigger response workflow, for example, you have some documents and they need to be summarized and period. You don't need anything else. So it's just a trigger response. Your document is uploaded to S3 bucket. You have a trigger. Model from Bedrock is called. It is summarized in the document and put the summary somewhere else. So agent reasoning is not required here because there is really nothing to decide on. And also, I wanted to stress, I want to underline the architecture flexibility of the agent, because as you already saw, we can have different number of action groups and action group functions. And inside each action group functions can be pretty much everything. So you can imagine you can connect to as many AWS services as you want. You may want to chain different kind of APIs, different kind of action group functions together. That gives you a great and a big flexibility in that sense. And also, as you saw in the action group settings, this is not necessarily Lambda. If you have some external functions that can be performed by user or some third-party software, your agent can return control, and you have the ability to have it back. And yeah, speaking about knowledge bases, there are different types of knowledge bases. You can experiment with different type of data sources. You can experiment with different vector databases. Or we didn't touch it, but you can have a structured database as your data source. So essentially, it's text to SQL workflows if you want to query your database. So it's kind of giving you more and more opportunities to connect to your internal sources. And what can be, because I showed you in this presentation, I show you a pretty like also layered, but a pretty simple setup of the agent. So you can quickly start doing simple actions with your agent and have connection to some AWS services, and then have a knowledge base connected. But you can go further. You can have one more knowledge base for structured data retrieval from databases. So, for example, user can simply ask about what was the sales volume from the last month, and agent will go to the connected database and query the database and return user number. It's pretty awesome. Also, you can use a multimodal data retrieval from the knowledge base. So you can also make use of pictures, of images, if you have a rich data with many images. You can use memory between sessions. You can so you agent can keep in memory what was going on with a certain user and can carry on the conversation. Also, you may want to use guardrails. Uh, one possible use of the guardrails is to check whether the output of the agent is not harmful, whether it's up to your policies. But you can also use guardrails with automated reasoning checks. With, for example, if your agent needs to solve some complicated problem with some calculations or with some heavy logic involved, you can use such guardrails so it double check the reasoning of the agent. And also, if your workflow is pretty complicated, you can use a multi-agent collaboration for such complex scenarios. So one agent would be responsible for just a piece of your workflow, and the agents can collaborate between themselves and solve the big task altogether. And that leads us to takeaways. The first one is that Bedrock Agent can automate complex document workflows. So you can offload these kind of pipelines to the agent. Building an agent, it's pretty easy, pretty straightforward. For basic tasks, even no code is required. Also, agents are very flexible. They can be customized for different document processing needs or for different needs. Also, for if you're curious, if you want to not to start from scratch, not to start from scratch, and you want to have this Lambda function with a pretty neatly formatted output, you can go to my repo that I created. You can find there even generated dummy documents, so you can quickly create and test your agent. You are welcome to use it. And also, I guess we are moving to Q&A. Yep. Thank you, everyone.
Thank you so much, Daria, for your very insightful session. While
Thank
we
you.
check if there are any questions, I have a few from my side. I'm sure Dharmendra would have a few from his side as well. So the first question I have, I mean, you demonstrated how easy it is to get started with Bedrock agents. So my very first question is with respect to the latency. When you are playing around, how is the latency, especially with the different kinds of models that you may have tried, and does it have an impact the response times depending on the size of the file?
I would say the latency, there are two main factors about latency. The first one is how complex your task is. Yeah, because agent is trying to think step by step. And if your task is just what's inside this file, I need to know something, this is pretty simple. And the model is giving you response like pretty fast. It's like just chatting with ChatGPT. Yeah. So
Right.
you can expect that the response is pretty fast. But if your task is like multi-step, it needs to go somewhere, extract some files, analyze these files, translate them. So there are like, for example, 8-9 steps involved. So you need to wait for a minute or two because all of this is being executed and agent is thinking. And you can track, actually, you can track the thought process step by step. So, and the second factor is whether you are using these Bedrock models from provisional output or just like on demand. Yeah, because I know that provisioned output can be expensive. Yeah, and if you're using it on demand, you can experience some, like model is not like a cold start type of latency. But as far as you can accept that this is okay, you don't need like a single like a 1-digit millisecond response. So you can allow agent to think sometimes. So I guess it's okay.
Got it. Got it. So one more question from my side. In towards the end of your session, you were talking about database as one of the options to the knowledge base, right? So can we use RDS as well for the same, or it has to be a vector database?
No. I was talking about like structured database, like a classical
Right,
database. So it
right,
can be RDS and it can be like any database you can imagine, like a SQL database. So it can translate your like user query to a SQL query, like top sales products or the
right,
sales amount like last month. So
right.
yep.
Got it. Got it. One more question, because you just touched upon the example of getting sales amount and stuff like that. So, yeah, I mean, in most applications, there will be data that you want to be publicly available or queryable, and there will be some internal data as well. So, does Bedrock have anything inbuilt to determine that, this columns or these data is something that I can expose, whereas certain data which is very internal to the application cannot be exposed to the end user?
I see. Yeah, I don't think that there is like a built-in capability in Bedrock itself, but as a on a database side, you can create a view, yeah,
Okay,
and yeah, work on a database end, and then
understood.
use this view when you're creating a data source for a knowledge base.
Got it. Got it. Dharmendra, you have any questions?
Yeah, so my question is there is a lot of buzz in the market right now regarding Amazon Bedrock, right? So how do you see it in compared to other services? Like it is another service from AWS where you are just configuring some plugins, and there is a agent thing which is doing stuff for you, or because we have seen this in other services also, like in AWS Glue we can connect the database, and then they do internally some process, bring the data to you in a different formats in your different tables and all those stuff. So how do you see it in compared to other services? Yeah.
Um, I think Bedrock has a great potential because first it was started just a playground, not a playground, uh, just a point where you can access different models. So I was thinking about it like a layers to for comfortable access for different models. So today I want to use Claude 3.7. Tomorrow maybe I will use some DeepSeek model or something like that. So it was started like that, but then it added agents, it added knowledge bases, and it now it has some service, some kind of workflow for uh, data automation processing. So I see that the service is like kind of becoming an umbrella of different Gen AI related things. So let's see what will be in the future, but it definitely worth exploring.
Got it. So Daria, we don't have any questions from the audience at this point. So thank you so much once again for joining us early in the morning. I mean, at least I had a very good experience, because I've been meaning to try out Bedrock agents, but now with your session, it's much more easier for me to get started. So thank you so much for your insights, and we really look forward to having you again on Serverless Saturdays sometime in the near future. Thank you so much.
Thank you for having me. Thank you,
Thank you
guys.
so much.
Thank you so much, Daria.
Bye bye.
Bye
Bye.
bye.
So yeah, so that was it from Serverless Saturdays for this month. We hope that you had a great time understanding two very interesting use cases. One is with respect to Swift Aid via so many AWS AI services, whereas the second one is about Bedrock agents. I mean, I personally at least learned quite a lot of things, new things about Bedrock agents and how comprehend, poly, connect, all these things can be stitched together to come up with a very nice aid system, dispatch system. So we will be back again next month. I think, Dharmendra, we've almost finalized the speakers as well, if I'm not wrong.
Yes, we almost finalized the speakers for you guys and for the next month. So see you over there.
Yep. So thank you so much, everyone. And if you have any interest in presenting, or you have any specific topic that you want us to cover, please do reach out to Dharmendra or me on LinkedIn, on Twitter, anywhere, or on Meetup, and we'll be more than happy to accommodate that. We are always encouraging new speakers to come and present, share their knowledge with the wider community. We really hope you had a great time and have a wonderful weekend ahead. Thank you so much. Bye bye.
Thank you so much. Bye bye.